All right, so we will go ahead and get started here. For those of you that have been here over the course of the last 2 days, I know you just ate lunch, but here I have some good news for you. The session you're in right now is the best kept secret at Tech Summit. You are about to see the best demos in this session that you are going to see in any session this week, and I'm putting a guarantee on it here. All right, so these are big words coming up. So everyone should be excited here. You're going to see some good stuff. We won't disappoint. So I've put a lot of pressure on you, Ken, now. So we won't disappoint you. You'll be happy that you attended. So I am Steve Michelati. I am on the engineering team, on the Azure Gov engineering team. This is my fellow co-presenter.
Hi, and I am Ken Hausman. I work with EPG on the U.S. federal side of the business, and I'm a solution architect. And we're here today to demo a lot of information about cognitive services.
So what we're going to do is we're going to spend the first few minutes, we're going to talk about cognitive services. That's our focus of our conversation today, but we're talking about it in the context of Azure Government. We're really excited because cognitive services is in kind of preview form right now in Azure Government, and cognitive services opens up a world of really interesting projects and workloads for your government projects. So what we're going to do is I'm just going to spend the first 5, 6, 7 minutes here talking about what is Azure Government. If anyone has already been in any of my previous 4 talks in the Tech Summit, you've probably heard this 5-minute spiel before. But I think it's really important for you to hear it because anytime I'm in front of any audience, I want to make sure they understand what is Azure Government. So you have that context first before jumping into the topic. And then after that, Ken is going to talk about Microsoft's AI strategy, and then we're going to do lots and lots of demos. So if you came here hoping to see 75 minutes of PowerPoint, you're going to leave very disappointed because you're going to see about the first few minutes will be PowerPoint and then lots of demos after that. Okay, so with that, let's get into what is Azure Government. Just give me a bump there on the slide.
We're going to kick things off with one other thing.
Yes, before we get to Azure Government, we want to give you a quick intro to the session.
So actually, let me give you a little bit of background about this. Basically, what we're going to do is play for you a video of one of the concepts that we've been developing at Microsoft. And if you guys haven't seen this before, this is what we call the Seeing AI app. Basically, it's an application that we've developed for visually impaired and blind people to be able to understand, in other words, see what is around them, whether it be objects, faces, people, things that are going on. And I'm just going to go ahead and play on this video just to show you the art of the possible and the things that we're working on in Microsoft.
I'm Saqib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind, and that's where I was introduced to talking computers, and that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives. And one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see 2 faces, 40-year-old man with a beard looking surprised, 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo,
Move camera to the bottom right and away from the document.
and then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do. But artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
I love watching people's reactions to that video whenever they see it for the first time. But
Ladies and
I think
gentlemen,
that gives you a
welcome
good
Dr.
idea
Harry
of the
Shum,
art of the possible.
Executive Vice President.
Sorry.
Next video playing here.
Yep, it was. Hang tight.
Well, thank you. Coming over.
Okay. And then I'm going to pass this over to Steve now so he can cover what is Azure Government.
Okay, so we are giving you an intro here. Now you have an idea as to what cognitive services is and the types of things we're about to show you in this presentation. And hopefully I've got at least a little of your curiosity up now. Okay, maybe he was right. We're going to see some interesting demos here. But first we want to talk about what is Azure Government, because we're really excited these cognitive services are coming to Azure Government. And we just, I think what you're going to see as we go through the demos today is the slew of possibilities that comes up for the different types of scenarios that this enables for government workloads is really interesting. So before we do that, I'm just going to spend 5 minutes on what is Azure Government. And the main takeaway here is that you need to realize that Azure Government is its own sovereign cloud. So we think about worldwide Azure, and you have 38 regions across the world. The US government cloud, Azure Gov, is its own instance of Azure, has its own dedicated data centers, its own dedicated network, own dedicated fiber. It's its own instance of Azure. And that's extremely important because these data centers are worked by only screened US persons. All the data stays within the continental United States. And so we don't have data going out to other countries or anything like that. It's dedicated for government workloads, whether it's federal government, state and local government. These are the workloads that is dedicated for. The other thing is that we have 100% federal cabinet agencies on U.S. government cloud, energy, veterans affairs. The U.S. government cloud consists of Microsoft Azure Gov, Office 365 for government. Of course, we're in all 50 states on Microsoft Cloud, 6 million users, 7,000 federal state agencies. Now, one reason I do put this slide in here, because this is worldwide and not just government, is because I think it's important to have that context of Microsoft's worldwide reach. 38 regions, twice that of our closest competitors. And when you think about the billions and billions of dollars that Microsoft has invested to build this cloud infrastructure, the billions that Microsoft is spending on security in these data centers, all of those learnings we get to benefit from on Azure Government. So even though we have our own sovereign cloud, our cloud technology is running the identical technology that's being run all throughout Azure through the world. Now, honing in a little bit more on our data centers, we have our two original regions, probably should say original regions, not existing regions, and this is in the east and the central regions. And then we have, a couple months ago, we had two more regions come on, our two DoD regions, similarly spaced right here. These are for DoD workloads. We had DISA level 4, and we now have DISA level 5 as well for those DoD workloads. So that's a huge differentiator for us. And we have two new regions spinning up later this year in Texas and Arizona. And once we have this, we'll now have 6 regions, which happens to be 6 times more than our closest competitor. And this is important for a couple of reasons. The one being the fact that these data centers are over 500 miles separated from each other. That 500-mile yardstick is very important because if some catastrophic event happens, like a horrible earthquake or a terrorist attack or some catastrophic event, you have the presence of peace of mind of knowing you have at least 500 miles in between those data centers, so you have geo-redundancy built in. Your data is still safe. You have certain areas of application you may have architected in a geo-redundant fashion so that even if some catastrophic event happens in another data center, you're still up and running in another data center. So when we just look at this map as a whole, we view that as a huge differentiator. In addition to our data centers, we have ExpressRoute. And we have express routes that are dedicated for Azure government. ExpressRoute is the technology whereby you are able to securely connect from your data center into the Azure data center, in this case, Azure Gov data center. And we have our ExpressRoute locations for government, unlike some other cloud vendors who kind of piggyback off their public infrastructure for ExpressRoute functionality. We don't do that. We have ExpressRoute meet-me points that are dedicated for government only. And it's our own fiber, and you have your own private line between your data center into our cloud at these meet-me points. The data is automatically encrypted up to the meet-me points. So again, we view this as a huge differentiator. Go on to the next. And then, when we talk about worldwide, we have I think 53 now certifications worldwide. It's really the second one, of course, that we care about for Gov, because this is the US Gov. So we have DISA Level 4 and 5 now. Level 5 is the highest classification, highest certification level you can get for unclassified workloads. We have ITAR, we have CGIS compliance, which actually I'll talk about quite soon here on the very next slide. Actually, I think this might be up to 26 now. This number seems to be growing every day, but whatever the number is as of today, 24 or 26, the states that we have CGIS agreements with currently covers 2/3 of the country's population. And again, the number of CGIS agreements that we have with states is growing every single day. Go ahead, Kat. We have FedRAMP. We had FedRAMP High. We had FedRAMP Moderate in 2015. We got FedRAMP High in 2016. And we have 32 services that are now authorized FedRAMP High. This is, again, a huge differentiator compared to our closest competitor. Azure Blueprint is a very important aspect here because I'm a developer, and so the last thing I want to do is read a 1,000-page document on how I can make my app compliant, and my eyes will just glaze over and I go right to sleep. But it's not a trivial undertaking. And what happens is sometimes people think, oh, well, if I just deploy to Azure Government, I'm going to be in compliance. That's not quite that simple. Yes, you are deploying onto compliant infrastructure, but you still have some responsibility as a developer. You might have to make sure you're not, storing passwords in clear text and using proper encryption and that sort of thing. We make this very easy for you. Our Azure Blueprint is guidance by us that enables you to help streamline that process. So as a developer, that's what I want to hear. I want to hear about streamlining my process so I don't have to read that 1,000-page document in the app. And whether you need to satisfy FedRAMP High or DoD Level 4 or Level 5, we have different versions of the blueprint depending on which one is appropriate for you and which certification you need. So definitely take advantage of the Azure Blueprint program when you need to do compliant apps. Just again, a word about our DoD data centers here. We now have L5, which is a huge differentiator. Again, the highest level you can get for unclassified workloads. So we're really proud about that. The Azure Marketplace, we now have, I think it's up to 180 items in the marketplace now. You have all kinds of Linux VMs and open source solutions and just a ton that are available now in the marketplace. And we have this number is probably over 100. Hold on a sec. This number is probably over 100 now. In the last 3 to 5 months, the amount of innovation that's been happening in Azure Government has been astonishing. And if you were someone that came to Azure Gov a year ago and said, okay, yeah, they've got a few things. I can do some storage, maybe some VMs, but I'm not that impressed. Come take another look right now. Because in the last 3 to 5 months, the amount of innovations that have been happening on Azure Gov is staggering. And the parity levels that we're now starting to approach with the Azure Commercial Cloud is getting very close compared to what it was a year ago. So we're really happy about all the stuff that's been happening in the last few months. You had a question here.
Yeah, apologies to interrupt. what is the difference between the Azure Marketplace and the Azure Government Marketplace?
Okay.
Are they two different things?
Yeah, so the question is, what's the difference between the regular Azure Marketplace that we think of and the Azure Government Marketplace? They are two different things insofar as there are different images that are put in each one, different solutions in each one. Conceptually, they're the same thing, but it's just that these are the images that have been approved for commercial, and these are the images that have been approved for government. So you may have higher levels of compliance or different solutions. You might not just have any open source solution may not automatically appear in Azure Gov. There may be a higher level of vetting by the items that are in the government marketplace. But conceptually, they're the same thing. So I definitely encourage you to just have a look, browse through what's available in each one. And again, we're growing every day. And the other thing to keep in mind is this. If you find something in the government marketplace, some kind of image, a Linux image, or whatever the case may be that you want to use, great, use it. But in addition to that, if you have your own images, whether it's Linux, I'm just saying Linux, all right, you see a theme here, right? Whether it's Linux or some other operating system, if you already have images in your current organization, bring those with you. You can bring your own custom images to our Azure Government Cloud. And we highly encourage that regardless of the operating system. We can support all OSs. Okay, so with that, I'm going to flip it back over to Ken here.
Okay. And for the next, I think, 3 or 4 slides, we're just going to give a brief overview of Microsoft Artificial Intelligence strategy. So if you're like me, I've spent the last 15 years in IT, working in the federal sector, most of that time as either a contractor or working for Microsoft for the last 7 years. And you've probably seen a massive shift going on in and around the IT environment. And really, you know, one of the things that we really need to start looking at is, I think this quote by Professor Schwab here really outlines a lot of the changes that have been occurring over the last 100+ years with the different revolutions that are going on, the industrial revolutions that are going on. And really what we're looking at is, you know, we're really on the verge of what he is calling the 4th industrial revolution. And this is all about productivity. And, you know, this kind of aligns with what Microsoft really has on the back of every employee badge. We have a quote, and it says this: "We're here to empower every person and every organization on the planet to achieve more." Simply put, you know, we're not here to beat humans. We're just here to help provide things to help you become more productive. And that's where our artificial intelligence tools also fall into this category. We're here essentially to democratize artificial intelligence. And, you know, this has really come about just because of 2 things that are going on at the same time. We have access to tons and tons of data now. We can store that, we can process it, we can analyze it. And then we also, from that analysis side, we have the compute power to be able to do that analysis. So that intersection is really what's bringing about this 4th industrial revolution for us. You know, just some of the things that, you know, artificial intelligence has impacted that you guys are probably already using that you may not even be aware of, like handwriting recognition. If you have a Surface Book or a Surface tablet, anything like that with a pen where you're going through and just taking notes in plain text, and then you hit convert. That's actually artificial intelligence that's empowering that translation behind the scenes from Scribble, my Scribble anyhow, to actual text. And then, you know, one other thing, I like the Surface Book, I have one here, and just being able to walk up to it, and the camera that is based in the device, it can log me in just by seeing my face. It's able to recognize a face based on artificial intelligence that we've baked into our hardware. So, you know, the last 30 years or so, we've spent teaching computers to think, act, and respond like humans, but now we're really on the verge of taking that and flipping it on its head. We're doing the exact opposite.
Is there a question back there?
Yeah, what's the degree of accuracy do you have? Is it foolproof, or have you seen any false positives?
So that's a fantastic question. To relay it to the rest of the audience, you know, what is the accuracy rate for, I'm assuming what you mean is some of our cognitive services. So I can jump into that in a couple of later slides here, but if I don't answer it, just pop up your hand again to remind me when we get to that section.
And we'll see that in some of the demos too.
Right,
We'll
that's why I said
revisit
we'll
that
pin it
question
down.
a couple times actually throughout the presentation here.
Exactly. And it varies by API, and that's why I say let's visit that whenever we get to it here in a second. So Microsoft has 4 pillars to artificial intelligence. As you can see here, we have agent, application, services, and infrastructure. Under agent, we have Cortana, and she's really the layer, the organizing layer for us that we use to allow our computers to get at data. She understands speech. She, recognizes who you are as a person, your habits, things that you do, things that you like. Last year, a little over a year ago, we had about 133 million users of Cortana across devices, iOS, Android, and Windows. And that number has been steadily growing, especially with the advent of Windows 10. In the applications pillar, many of you are probably familiar with some of the tools that I have listed here. I'm not going to be able to jump through all of these, but I am going to try to just briefly touch on them and give you some examples. For example, underneath of Office 365, most of you are probably familiar with applications like Skype or Word. Let me just take Skype, for example. In Skype, we recently added the ability to do translation on the fly of conversation from your native language, one of 12 languages, into one of 60 plus other languages now, on the fly. That's just another great example of productivity. Word, if you guys use that at all, we have the ability to not just understand a word or give you a thesaurus to be able to give you a different word, for example. We can actually understand the structure, the context of the entire sentence, and provide you input to increase your grammar or your style of writing. So we have a lot of AI that's just baked into products that you all are probably already using and you're not even aware of at this point. Underneath the services, this is where we're going to focus a lot of our time today, especially with Bot Framework, which I might get to touch on very much later in this demo, and also with cognitive services, where we're going to really hone in on today. Just a couple that I want to pinpoint here, just to give a brief highlight. For example, the Translator API that we have that runs within a lot of our tools. Recently, we were able to take with our Microsoft research teams and basically go against a standard test that NIST provides. And with that test, the switchboard test, we were able to prove that our systems can have a lower word error rate than human beings in a similar context of them being able to pick up a phone and listen to a conversation on the other end and accurately translate that conversation. Additionally, we also have ImageNet, which we have used to create a deep neural network of 152 layers. And with that, we are able to recognize objects within that image with supreme accuracy. I'm just going to jump down to another tool. Maybe we also have some commercial applications that are using some of these cognitive services. Things like Uber. If any of you have used Uber the last 2 days to get in and around the city, they're actually using our cognitive services, our Face API, to take selfies by the drivers themselves to verify that they are the person indeed operating that vehicle for your safety as well as their own account security. And the last pillar I want to touch on is infrastructure. Here's where we have our massive compute nodes. Our CPU fabric at scale is incredible. Additionally, one of the things that really differentiates us from competitors is that we have GPUs attached to all of our compute nodes across the world. So with this, we can take our FPGAs and crunch through tons and tons of data. I just want to take just a second, focus on what you're going to do next. Blink. And the average human takes about 0.2 of a second to blink. If we were to take most of our compute nodes with our FPGAs across the world and take Wikipedia, for example, where we have roughly 5 billion words in English, we could translate all of that content in about 0.1 of a second using our compute power. And it is accurate. So, at all this, humans are really the center, but what we're here for is to help you be productive. And we're going to jump into some other stuff here in a second. I want to point out some figures that IDC had recently released. And they talk about how cognitive computing is really going to take off in the next couple of years. As you can see here, by the year 2020, there's going to be roughly $18.2 billion spent on just this industry alone. And by 2018, half of all consumers are going to be interacting with cognitive computing on a regular, possibly daily basis. And some of the things that we really think we are going to focus in on here will be things like fraud analysis, investigations, and the defense industry, and possibly even connected vehicles. And I think that really aligns well with some of the stuff that we're talking about here in this government-oriented session. So today we're going to jump into how we can use cognitive services and what these APIs are, and how we can help you make your applications more intelligent. If my slides would progress. So what are cognitive services? They're easy APIs. Essentially, all you have to do is just acquire a key from your Azure portal, and with a few lines of code, plug these things into your applications. And these applications, as you see here, can reside on Windows devices, Android devices, iPhones, iOS, whatever it may be, and we bring these to you on your own terms, whether it be Python, C#, Node.js, whatever it may be. We make them work for you. And additionally, they are highly supported. Not only do we have not only do we contribute to GitHub, but we are the #1 contributor to open source in the industry. We also have a lot of support on Stack Overflow, MSDN, and the last one I want to point out here is user voice. If you all aren't familiar with this, this is just a place where you can go, log your comments, and provide input on how we can make our products better for you. So cognitive services span 5 categories, and we're almost done with this, so just hang in with me here. Vision, speech, language, knowledge, and search. And they just allow you to tap into a rich set of APIs to process everything from faces and pictures to video to understanding language. As of right now, we have 24 APIs that are available. Now just keep in mind, a little over a year ago, we only had 4 that were released to the public at Build. And since then, we've been steadily adding API after API. And as Steve alluded to, we are bringing these to Azure Government. All of this cutting-edge research that relies on machine learning algorithms underneath the hood, they're going to be brought to you so you can tap these into your applications and use the power of our cloud. Today, we're going to be focusing in on these 6 APIs in some of our demos that we're jumping into next.
Quick question on that.
Yes?
So out of the total, are those 6 approved for Azure Government, or are all of them?
Yeah, so as Ken mentioned, we have 22, 24, somewhere in there, APIs total for cognitive services if you're using Azure Public. We're slowly bringing them to Azure Government. So as of today, I don't even know the exact number, somewhere maybe around a half a dozen, maybe 5. But a week from now, a month from now, that number is increasing. So you can get part of the private preview program right now. And if the API you're interested in is already there, great. If it's not, talk to us, and we can talk about getting that particular one expedited.
Okay. Do you want to jump into one of your demos at this point?
Hit the 6 there. Okay, so we've given you guys an overview here. We've talked about what Azure Government is. We showed you the intro video to show you the art of the possible. And now you have an idea of Microsoft's AI strategy. We want to spend basically the rest of the time showing you demos, some cool demos. So the first one we're going to talk about comes under the speech category. Specifically, it's the text translation API. And what I have is a simple Windows app here, and I want to translate a document. Now right here what I have is a Chinese document. It's actually just a text file right here. And it's actually the book, The Art of War, okay? So what I'm going to do is I have this application here, and I'm going to find this document right here on my file system, and I'm going to hit the Go button and translate it to what language? We're going to translate it to English right here. You can see the drop down right here. And when I hit Go, I want you to pay close attention to this part of the screen right here. You're going to see a second file that's going to appear. So let's do that now. I'm going to click Go, and it's going to go out and make that API call. And just like that, you see a file has just appeared. You notice that file has a .en extension for English. So just in a matter of seconds, it's gone out and made that HTTP call. It's doing that translation of the document incrementally, and just within a few seconds, it translated it. And here's the here's the English translation of the Art of War right here that's sitting here on my file system. That happened just in a matter of seconds, going out to call that API. Now, sometimes people look at that and they're like, wow, that's cool, that happened fast, seems a little magical, not really sure what happened behind the scenes. So I'm a developer, I always want to make sure everyone understands how I did it, how it happened behind the scenes. So I'm actually not even going to show you C#, we're going to go even one level beyond that, which is the direct HTTP call that we make to get at some of those translation services here. So what I have is I have a key that we've acquired right here from my portal, and I have an endpoint to get a token issued. So I'm going to send that request right here, and that's going to come back with this big blob of data down here. Okay, and I'm just using Postman. Postman is just a nice little tool to help you make HTTP calls. It's a free tool you can download. So I'm going to copy that big token that I got returned right here. And just to make it easier, because you can specify this on the query string, but that's kind of a pain to do. What I'm going to do is just a little Postman trick where I can come in here and just put it in here like a variable. And let's just put it right there. And I'm going to paste in the new token right there that I just retrieved and save it. And I'm saving that in a variable called CS_bearer token. All right, so remember that variable name, CS_bearer token. Now with that token saved, that variable saved, I can come over here and I can start calling endpoints. So right here, here's an endpoint, get languages for translate, and I give it an app ID of that CS_bearer token. So that token I just got for authentication, I'm sending that in on this endpoint, and I want this endpoint to tell me what languages I have available to translate into. Okay? So I'm simply going to send that request right here, and you can see I've gotten a list of languages, and these are the language codes. All right, so now I know the various language codes that are available to me to translate into. Great. Now let's do a translation. So I'm going to come over here, and what you're going to see here is I have an endpoint here, Translator API, and specifically the translate endpoint we see right here. And I'm again sending in my CS_bearer token. And right here, you're going to see the next parameter is 2. 2 equals FR. So that I'm going into the language French. All right? And what am I going to translate? Let me scroll over a little bit further here. So the text is the next parameter you see. And the text equals the quick brown fox jumped over the lazy dog. All right? So now let's send that request, and just like that, we can see that we have the translation in French of the quick brown fox jumped over the lazy dog. And I can, again, use different languages. So when I did this get languages here, let's say I want to get Chinese. So I'm going to copy this code because I can never remember it. I'm just going to Control-C to copy, and I'm going to replace FR with the Chinese code and send that, and now we have the Chinese translation of the quick brown fox jumped over the lazy dog. So that's just to show you how quick and easy it is to get up and running. So we talk about different languages. You're maybe a C# developer, a Node developer, Python. All those languages can make HTTP calls. And because Cognitive Services is exposed to you in the form of simple HTTP APIs, this enables you to easily integrate it into any application that you might be building. It's not like we give you like a Windows application and here, use our Windows app. No. We're giving you APIs, so you can build your own Windows app or mobile app or iOS app, totally cross-platform, any platform, any language that you want, it's in the form of these APIs. So this is just one example of text translation. We have speech translation and other services, but this is the first demo we want to show you just for translation. Before we go to the next demo, any questions I can answer about the demo I just showed? Yes?
So are the calls free up into a certain volume? Is that the way it works?
So the question is related to cost of the calls, and there's different levels. So if you have like S1 versus S2, in the portal it'll show you like, it will give you this many calls are included per month or this many calls per month, and those prices can vary. So just look at the Azure pricing calculator. But basically it's different levels. Like one level you can say 20 calls per minute is within the realm they give you. So depending on how much volume you're doing, you can pick the appropriate one that's going to be best for you. Yes?
So how do you account for dialects or different wording?
Yes.
If you read a Colombian, Garcia Marquez, for example, you read a Colombian book, the wording can become slightly different, right?
Yep.
And even within the country, so you have to do that.
Yeah, so the question being asked has to do with variations in dialect because, and for example, there's slang that gets used, and some of that might be regional in one location that's totally different in another one. And that is absolutely taken into account in a couple of ways. Number one, backing all these APIs, I mean, to us, it just looks like the simple API we're calling, but behind the APIs, there's an extensive library of machine learning algorithms that are being constantly updated to take in a lot of those dialects into account. In addition to that, there are APIs that you can call to specifically train the model in certain dialects, in certain slang, for example. Maybe there's slang that's introduced that Microsoft doesn't know about yet. There's APIs you can call to train the model in that slang so that the translation services can become more intelligent. In fact, that is central to what Microsoft is doing here because we want people to train the model as much as possible so that it can be accurate. So that's an extremely good question and highly relevant. Yes?
Is there any performance limitation in terms of making a call? Say, for example, if I wanted to translate a book like Moby Dick, can I use this and it'll translate the entire book?
Yes, yes. So the question has to do with performance and can it translate an entire book? I did one sentence here, The Quick Brown Fox. Actually, the Art of War was a couple thousand words that I just translated. And if you want to translate Moby Dick, you absolutely can do that. It will take a few extra seconds beyond my Art of War, but you absolutely can do that as long as you have, you're probably going to need more than 20 requests per minute, depending on what level you've signed up for. But yes, you can absolutely translate huge volumes of text in a short amount of time. All the way in the back.
Is it making use of LIPS, the language interface packs, the same ones that SpeakServer and other technologies have used?
Lips.
I'm not.
Language interface pack.
I am
I'm
not familiar with
that
LIPS.
one.
So if you're asking about how,
But that's how,
Are you talking about Lewis?
what's that?
Are you talking about Lewis?
No. LIPS, language interface packs, it came out of the Office team, and it's what does the localization.
I do not believe it is, but we'll follow up on that one after this to make sure.
Right.
Yep. Okay, so this is probably a good time to move on.
Yeah.
You want to take control of the monitor?
I think you had possibly one more. Oh, wait, no.
You're going to do speech and yep.
Yep. Okay, so moving on, we're going to cover, nope.
I hear you.
Moving on, we're going to cover now one of the open source projects that we have out on GitHub. Chris Wendt continuously updates Speech Translator. And as you see from the link up here, you can just go out and freely download this. And with one of the keys, you can begin using this application that I'm about to show you. I've downloaded this code and compiled and ran it in Visual Studio. And as you can see from this, it's just a really simple graphical user interface. Like I said, it takes account settings with a key. And I can also do a few things with this program that I really like to show to people. We can log all of the audio that is sent, record that. We can also record in a WAV file all of the audio that is transmitted back in the translated language. And then we can also provide a written transcript of everything that has occurred during that entire session. In this, it's picking up my microphone array that I have built into the machine. And I can also input directly from an audio file as well. In this case, I'm going to output the audio to my headphones, and I'm going to just select my native language of English to speak. And as you can see here, we actually have 12 languages that are now supported from spoken language. And we'll translate into one of 60 languages that we have in this list. Hello, my name is Ken. How are you? We didn't get audio back on that, but you would have heard it speaking. Would you want to try that again? Yeah. Okay. Hello, my name is Ken. How are you today?
Hola. Mi nombre es Ken. ¿Cómo te va?
So you can see this can be used, like I said, with one of 60 languages to translate into. And I just wanted to show you real quick some of the logging capabilities that we have within this program. Everything that has been sent to and from that service, I check that box to record all of that audio here as well on my local machine. And I can even pull up some of these translator logs to show you what was sent and what it responded with. Again, you can go out to GitHub, pull this down, test it out for yourself, kick the tires.
Okay, so I'm just going to real briefly show you. Yep, here we go. Here's Visual Studio, and I have the code open to the app that he just showed. So I'm going to hit F5 to start debugging. And I just really, again, I'm just going to show this briefly, but the main thing is I want to be able to show you how easy it is to get started. So let's see. Well, let me hit start here. Hello, how are you doing today? And I've hit a breakpoint in here. I have a breakpoint in the code such that it can come in and actually get the results of everything that gets sent off, message type, text, and I can actually step through the code. I can see it's set everything into a byte array. So when we talk about like on Postman, I've actually sent off an HTTP request. It's the same thing here. This is just using WebSockets instead of HTTP to do more real-time data transfer of the data. But the key here is that you can actually get into the code, you can set breakpoints, you can actually see it happening real time. And this is the speech client class right here that is the heart of the application. And this entire class, 290 lines of code. All right, so that's the end of the file right here, 290 lines of code, and it has the heart of this. So not only are we providing you APIs that you and your developers can use, we also provide code samples on GitHub that you can download if you or your developers need help getting started on how to consume these APIs. And not just the simple cases like using HTTP, but even more the streaming cases where you need to use WebSockets over a real-time stream. So again, encourage you to come down, get some of these demos, experiment with them, put breakpoints in here, see how the code is constructed, and let us work with you on building apps. Yes?
Is there any offline version of the APIs? Or do all of them
So the APIs are all, the question is, are there offline versions? The cognitive services, as we're talking about Azure Cognitive Services, are all meant to be consumed by real-time HTTP calls, not offline services that you can just put on your machine locally. Okay.
All right, cool.
Question, do you have to have an Azure account to do this? Or
Yes, so you have to have an Azure account, yes. It's just like any other Azure service. Like you're adding a storage account, you add a cognitive services account. Same principle, and you get your, just like you get your storage key, you get your key for your cognitive services. Same principle.
Okay. All right, for the next set of demos, we're going to pull up another application, which we call the Intelligent Kiosk. And again, this is freely available directly from GitHub. A lot of our documentation, links, et cetera, are out here on our Cognitive Services page. If you just go to the Docs and Help, go to Documentation or SDK and Samples, we can actually get to some of these links here. And the one that I'm going to select right now, like I said, just typed in Intelligent Kiosk, and it linked over to GitHub. I went ahead and downloaded and compiled and began to run this application. And let me pull it up here. Whenever you first open the app, this is what you're going to see right here. If you go to the Demos tab, we can actually take a look at some of the highlights of some of the demonstrations that are available with this application. So one of the ones that I want to point out from my first demo here is going to be the Face API Explorer. And by default, I haven't set up anything behind the scenes to recognize myself with this application. So what it's going to do is just make a call using the APIs behind the scenes and attempt to recognize me And since it didn't, since it does not have anything in its own database, it will just attempt to pass back an approximate age. And one of the things that you can see here are the landmarks that it is looking for behind the scenes in the API. We're calling these out specifically because we have 27 different points across a human face that we're looking for in order to develop data points on that person, to be able to differentiate Bob from Ed, for example. So what I'm going to do now is go into my face identification setup and create what we call a person group behind the scenes. So I can create a collection of people and drop images into those collections so that I can track different people. And I'm going to create objects for myself and Steve here. After I create my group. You can actually see that this application is also making a call out to Bing and attempting to find people by my name. And it's also going to reach out to Bing and take a look for other images that might be related to Ken Houseman.
The interface you're using, is this part of Azure? Or is
This is the
This is-
yeah.
Sorry. This is just the intelligent kiosk app. And yeah, this is just an easy way for us to demonstrate how we're making all these API calls behind the scenes. So just like you could with your own application, you can use this same structure of code essentially to get at the exact same thing. So I'm going to add my pictures. And then I'm also going to create Steve in here as well.
I'm going to spell my last name.
Nope, I got it.
I am. Actually, it wasn't Bing.
It was.
So is it that we would just want to upload one picture for each person or multiple pictures? How does that work?
That's a good question. Typically, what we look for is 7 seems to be the magic number for identification for people. We have an ideal scenario because we have fresh pictures, but people's faces, just like their voices or any other thing on a human, stretch, change over time. So that's going to impact the quality of the rendering, essentially the output. So what I'm going to do now is go back to the Face API Explorer, and we're purposely going to have an error show up here in a second. It's not identifying faces, but it does have an object behind the scenes, a group behind the scenes. And it's still passing back an approximate age. So just because we have these objects created, we still have not yet trained our models. And this is what I wanted to pinpoint here to highlight for you. Even once you upload all these objects, you still, like I said, have to train that model behind the scenes to allow the APIs to go through and understand the images that we've passed back.
So you hit that button and said, okay, I've done uploading my pictures, now go process them and train the model.
Exactly.
So it's kind of like we talk about training the model for translation. Here we are training the model for facial recognition.
Exactly. So as you can see here, I have a 97% accuracy that I am Ken Houseman in this photo.
You got 3 years younger too.
I did. Well, actually, that's about right. And if I can, let's just grab you while we're out here. Smile.
I got 10 years older. Okay.
That's good. All right.
We need more pictures to train the model a little better, I think. That's what it is. There's a question.
Yeah, so do all the cognitive services require the training? Because I noticed, and the reason I ask is because in text translation, you can go through the process of training it. Do all of them have to do that, or does some kind of have them baked in?
Some already have them baked in, like you saw with Translator. We're already training the models and everything else behind the scenes, but language doesn't change too much over time. We might add some slang here and there, and we're accounting for that in our models that we're continually updating behind the scenes. But Face API, for example, speaker recognition API, those are things where you're going to be passing over your own private data sets. And we don't have access to that. There's no way that I can collect these images and train them across tens of millions of people across the world. But great question.
So in follow-up to that, does Microsoft have like a pool of images that it could search against? So I guess it would be the image.
The Bing images, right?
Yeah. So
Would that be something available that I could train my app against Bing's images?
yeah, that's a good question in terms
Keep in
of.
mind, though, are you doing facial recognition? So the images that are going to be in Bing for that are celebrities, right? And actually, Microsoft Dove has a celebrities API. But tip.
Say, for example, if I wanted my app to recognize what a basketball looks like, or something like that.
Okay,
Interesting, you should say
Yeah.
that. Let's hold that till our next demo.
hold that thought. Yeah. Question in the back?
These services, they're the Azure stack. So if I'm in the Azure Gov, am I making this call inside of the Azure Gov or am I going outside?
So can I answer that question? So
please.
keep in mind, cognitive services is a series of endpoints. And because we are on the Azure Government Cloud, we have different endpoints than the Azure Commercial Cloud. Our endpoints live inside the Azure Government Sovereign Data Center. So when you make a call to the endpoints for Azure Government, you're staying within the confines of the Azure Government space, not in public. And frankly, that's why we can't just snap our fingers and bring all 24 APIs over at one time. It happens gradually because we need to make sure the APIs are brought over one by one and correctly set up. So when you're using cognitive services within inside of Azure Gov, it's using government data centers.
So in effect, our services will be behind in terms of efficiency or features of the public. In other words,
So the way I would characterize that is public currently has 24 APIs. In government as of today, we have about 5 or 6. If you have an API that you want to get using right now today, join our private preview program at Azure Government. If the API is already available, great. If not, talk to us. We will expedite that API getting moved over to Azure Government as quick as we can. If you have a scenario you're working on today, you can talk to me after this session and we can expedite things for you. Eventually, we'll get to full feature parity, but it will happen over the course of the next few months.
Okay, I'm going to cut down on some of the talking that I'm going to do in some of these demos just so we can get through all this information in the next 18 minutes here. So another one that I want to quickly highlight is real-time crowd insights. And this is just a demo just showing a video stream. Instead of photos, we can actually use these very same APIs to make calls use these very same APIs to make calls directly from video streams to be able to do face recognition. And as you see here, it's actually recognizing multiple people within the exact same frame. Additionally, it's also cataloging the approximate ages, as you see down here in the bottom left, and also our moods. Right now, we both seem to be pretty neutral.
I'm happy now. I see Karina out there laughing at me, so.
So would law enforcement be likely to use this, like when people are rioting, causing trouble, to take pictures and try to identify them?
The applications are limitless. Let's just put it like that.
Just out of curiosity, again, kind of on the same line as performance, what's the maximum amount of faces you can
Yeah, actually, we can track up to 64 individual persons in an image currently. Minimum required size is somewhere around 36 by 36 pixels. There is also a maximum size as well for the image that you can pass over to the API. And then real quickly to jump into this demo, I just wanted to show also how what we could do with this API theoretically is catalog individuals in a series of images. And say, for example, if we had FOIA requests that we needed to complete to release images, what we could do is catalog 1 or 2 people and just say, hey, anytime we encounter this person within any of the images that we pass through our process, we could essentially blur out the face or cover it up, as you see right here with some of these real-time face effects. So like Steve just alluded to, the possibilities are really endless with what we can do with our APIs. and to help you with your mission.
Are you showing vision or?
No,
Okay.
not yet, if we get to it. So, oops. We had these three.
Face.
Face API dev demo.
Switch. Okay. So, I have another picture here, okay? And we showed you examples of the Face API, and you had the rectangular boxes that were drawn around the faces. Again, I want to show you, from a developer perspective, how some of this gets put together, all right? Let me close that. So what I'm going to do is I'm going to click this button called Detect, and it's going to go out and make a real-time HTTP call to the Face API. So I'm going to go ahead and click, and just like that, within a second, it came back, and I would have red boxes on each face. And if we click any of these, we can see, okay, gender, female, no glasses, approximate age, do they have sideburns? Okay, 72 is the approximate age, 12 is the approximate age. So we can see each one of these, we can, and let's say we only want to look at females, we can uncheck the males, and there's just the females. So again, if you had 64 people in a photo, you could say which ones are wearing glasses, smiling with facial hair. And you could quickly filter out like a Where's Waldo type of thing. And the other thing to keep in mind is what's happening behind the scenes. If I'm going to show my, so the AJAX call that's happening behind the scenes, I'm going to click that blue detect button again, and you can see there's the API call that happened under the covers, and we had this array of face API come back, and we can look at each one. Okay, there's face attributes, approximate age, 35. Here's some metadata we have for facial hair. And we could see this person had no facial hair, beard, mustache, sideburns. It was a female. And we also have face landmarks. So the face landmarks are actually null because I said, no, don't even bother sending me back the face landmarks. I don't need the points of where the nose and the mouth are. But I did ask for the face rectangle back. So we have a top and a left and a height and a width of the face rectangle. So the only thing that happened is there's just a simple data exchange happening across the wire. And then what I did is I took that metadata and I just wrote some JavaScript to draw a red box around the face. So it's not that Microsoft is drawing the red box for you. Your developers, you get to have that fun. Your developers get to have that fun. They'll draw the red box because your application may look different than my application. So when I get the code back, it just looks like when I have this get method right here, I call Face API detect. I can come in here, look at the detect. I can call the Cognitive Services URL. And we can see this is an image that's sitting here in US GovCloud API. It's a JPEG of the Trump family. You can see the parameters being passed. So I have the attribute of gender, whether or not the person's smiling, whether they have facial hair, whether they have glasses. Is it going to send back their age? So I get to control which pieces of metadata come back. Maybe I want this to be as quick as possible. Don't even bother sending me facial hair. I just want to minimize the payload of the JSON payload that comes across the wire. Great. I'll make sure not to include those. So I make the request and I say which attributes do I want to come back. And when I get the request back, I can get the data. And here's the JavaScript data. And I'm just populating some JavaScript to say, OK, here's the face ID, gender, glasses. And I can loop through each one, and I can set the rectangle, the height, the left, the top, and the width. And I'm just writing some code to some JavaScript code. Maybe you're writing C# code. Maybe you're writing Python code. Your language of your choice. That's the nice thing about these Cognitive Services APIs. They're just HTTP APIs, so you can use the language of your choice, cross-platform. And you can see that I just wrote maybe 100 lines of code to be able to basically pull off this entire demo right here. This is just running ASP.NET Core. And again, you can click each one, and depending on who you click, you can see the attributes over here. Now, one thing I could do is if I had trained the model, then I could also do facial recognition. Like maybe I don't recognize the child because we don't want to have names with that, but we will recognize the President of the United States. And so you would have facial recognition for that person. So again, it's just a matter of training the model and putting it into your custom application. Are we showing computer vision?
Yep, okay. I'm getting ready to right now. We still have barely enough time left.
We're good.
Okay. Earlier, we had a member of the audience ask a question about using one of the APIs to actually do object recognition within photos. unlike the Face API that we had been previously demonstrating, another one that I want to point out right now is our Computer Vision API. And what we can do with this is what it alludes to. Take a picture and then recognize and describe objects within that image. I'm going to use the Intelligent Kiosk app again, just because it's a really simple interface for me to be able to centralize a lot of my demos. So what I'm going to do is just do a search for a bike on a trail. Whoops. And again, you could select an image that you already have on your local machine and then feed this directly into the application as well. But what I'm going to do here is just select this image and then run it directly through the API. And what it's going to do is come back and describe a lot of the objects that the API identifies within that image. As you can see here, we have grass at 100%, a bicycle. It's pretty certain that it's there as well. We have things like dirt, tree, woods, outdoor, and wooded. And then what it can actually do is take all this information and then, in a context, be aware of what is really going on. It's saying that I see a man riding a bicycle on a path. And this goes back to some of the other things that we showed earlier in that Seeing AI video at the beginning of this entire demonstration. We're able to take these APIs and then do real-time analysis of things that are occurring in your world. What I can also do here is if I had an image that had text in it, I could turn on OCR, optical character recognition, and be able to correctly extract words that it sees within that image.
So if it was like a speed limit sign or a street sign of some kind.
Yep. Exactly.
Oh, there's a question back there.
Okay. Question.
If you were taking a picture of your monitor, an app that's running on there or a web page, did it interpret all that and read it out as text? That's what I'm trying to get to. By the way,
Okay.
you're blind. This is making an app that is a legacy app, spending the resources to make it fine. Take a screenshot picture of it, and the software can read it back to me.
Yep. Yeah, so think about the video we showed you in the very beginning, right? Where the individual was blind and they're looking at the menu, whoop, take a picture, and it can read the menu to them. So that's a similar principle what you're talking about there. Yep. I have not personally done it, but I'm going to now.
Yeah.
There's a question right here.
Sounds like a good blog post.
Yep.
Yeah.
But you have all those caveats around that, right? And that's something to look into because maybe more, that blind people will see and have it help.
Yeah, absolutely.
Yeah, totally.
Okay.
I was going to say that I'm just going to skip over some of the other demos that I have here. But what I wanted to point out is that you can go to our Cognitive Services webpage and perform a lot of these very same demos as well, even without our Intelligent Kiosk app.
So Microsoft.com/cognitive-services? Okay.
And so you can go here and feed in a picture, pull out data points, for example, do face verification or face identification. And then each one of these pages have different tests on here. So I'm not going to have time to actually get to some of the speaker recognition API demos and things that I wanted to talk about today, but
the speaker recognition would be like if you had your device and I tried to unlock it with my voice, it would recognize that's me and not you and wouldn't let me.
Exactly. Yes. Okay. And then real quickly, one of the things that I wanted to point out is that going into the keynote yesterday, many of you may have noticed the car that was sitting there with the lights on. And that car if you had a moment to actually stop by and chat with Scott, the person running the booth, he would have described that this is what we call our Microsoft Advanced Patrol platform. And since this is a government-focused session, I just really wanted to take just a minute to highlight that vehicle out there. And it's going to be here in the DC area for the next 6 weeks or so. So if you have other questions, feel free to ping me about it. I'd love to put you in touch with Scott and also be able to demonstrate some of the capabilities. But what I want to show here is like, this is really, the art of the possible for public sector, whether it be safety, security, military, police. We have a lot of devices that, a lot of devices that are actually baked into this vehicle. We have a HoloLens. We have a drone where we can capture live video. We have body-worn cameras. We have IoT devices that are baked into some of the holsters. We have license plate readers that are on the vehicle itself. And like I said,
gun comes out of a holster, body-worn camera automatically comes on.
So yeah, not only that, but we could also, like Steve was alluding to, trigger an alert to bring other officers in the area whenever a weapon is removed from its holster. Or if we wanted to, we could also trigger that body-worn camera to begin pinging against the Face API to find individuals that it sees within that video frame.
Maybe they've trained their model with the database of known
keep losing my
criminals.
voice here. Exactly. So, yep, we could even do face recognition if we see persons in that video image or that video still, that are on a wanted list of some sort. And this has a whole array of devices that would be really useful in a lot of public safety scenarios. And again, it's all tied back to Azure, tied back to the internet, and has a lot of baked-in capabilities that would be really useful. The other things that I just wanted to briefly highlight, we have some links up here. So if, again, I see a lot of people snapping photos, feel free to do so at this point. All the software that we have demonstrated today are linked right up here. We have our documentation to the APIs as well.
And we'll make sure that the slides are uploaded to the Tech Summit site. So by tomorrow, you can log on to the Tech Summit site and download the slide deck so you can get all these links. Sorry, was there another question in the back? Oh, yeah. Yeah, don't worry about having to take a picture of everything. We will make sure that they're uploaded to Tech Summit site. At least check back by tomorrow. We'll make sure they're up there.
Okay. And then, question.
About Azure government and the usage of things like the text translator, for example. So in the federal government, if I'm working in a classified network, say I'm dealing with top secret or secret documentation, is it approved to use, say for example, text translator to grab those type of documents and say convert it from English into French and send it to their French allies or something like that?
That would probably be ultimately a question for your security officer, I would believe.
Yeah, so the question is relating around the security, just to make sure everyone hears it for the video. If there's a classified document and we're doing translation, is that automatically approved? And I'm going to punt on that because, as we said, we would want to have a discussion with the security officer first before giving a definitive answer on that.
So then the follow-up question is, if there's approved Azure government cognitive services, then what about the services are approved by the government, if not for accessing that content?
Let me follow up with you on that question right after the session because we just want to get through our closing.
Yep, and then with the last minute we have here.
Actually, the one thing I would point out here, actually, did we have the... Okay, so there's not, oh, here it is, this is the one. So this link, if you want to sign up for a trial for Azure Gov, the link right here, link to our documentation, or to our blog. The other one I want to call out is we have our government meetup, our Azure government meetup every month in DC. A thriving community, you'll see me there every month. Come, ask questions, join the community. We have probably 100 people there every single month, just a few miles from here.
1776.
Yeah, the 1776 building. So I definitely encourage you to come check us out on our government meetup.
Okay. And then one last thing that I also want to point out. For those of you who have stuck around, we also have some stickers up here sitting on the projector. Some CNTK, Cognitive Services, and Bot Framework stickers. So feel free to grab a couple of those. And if you have any other questions, just come see me or Steve.
All right, thanks a lot.
you.
We'll hang around, but if you have questions, but thanks a lot for coming.